Good morning, good afternoon, and good evening. Thank you for taking the time out of your busy day to join us for this very special web event. Joining us from Mojo Networks is Sri Ram, our Director of Product Management. He has been with Mojo for over a year and a half, and he drives the roadmap for all of the wireless networking products, including access points and the cloud. Sriram has over 10 years of over 10 years of experience in the Wi-Fi industry, serving multiple roles including engineering, technical marketing, and product management. Our special guest presenter today is Simon Brand from Qualcomm. Simon is currently the Director of Product Management for 802.11ac Wave 2 and has 30 years of experience in the wireless industry. Without any further ado, I'm going to go ahead and pass the floor to Sri, who will begin our presentation today.
Perfect. Thanks for the intro, Erica. Welcome everyone once again. A quick look at the agenda for today's session. We'll start the session looking at some key industry drivers accelerating the adoption of Wave 2, and we'll also look at some of the use cases for Wave 2 across different industries. We'll then have Simon dive deep into Wave 2 standards, look at where Wave 2 is from a standards perspective, talk about some key Wave 2 capabilities and its benefits, and then talk about the new Qualcomm chipset, the QCA9994. And then we will wrap the session with a quick introduction about our newest Wave 2 access point, the C120. With that, let's get started. Okay, from an industry landscape standpoint, if we look at some of the key factors driving the adoption of Wave 2, definitely the growth of devices is the primary one. According to Gartner, there will be 20.5 billion IoT connected devices by 2020. And we expect that the majority of those devices will be using Wi-Fi as the primary mode of communication. These IoT devices include the wearables, all the sensors at your home that enable the smart home ecosystem, the environmental sensors, industrial sensors, the sensors that get deployed in your cars, etc. And we will see a massive explosion of these devices in the next couple of years. We've already seen that trend today. But also remember, this is on top of an explosive growth of the smartphones that we already see in the wireless network. So combined, both the IoT and the smartphone mobility trend will pose serious capacity or high density challenges and issues to the wireless network, which will drive the adoption of newer wireless standards. From an application standpoint, especially with more users becoming more mobile, wanting to be accessing all applications at fingertips on their mobile phones, we will see more applications, more bandwidth-hungry applications being accessed over the wireless network. And on top of that, all the IoT devices will also consume huge amount of data, putting a strain on your wireless network. So both of those will need more capacity to be provided on the wireless network, again, driving the adoption of newer wireless standards. So on one side, you have a massive explosion of devices connecting to your wireless network. And on the other side, you have these devices running more bandwidth-hungry applications on your wireless network, which then leads to the fact that we will definitely see an increase in the average consumption, data consumption per device in the coming years. And again, according to reports, there will be 4.5 gig of average monthly consumption of data per smartphone by 2020. And this is almost a 5-fold increase from today, which is less than 1 gig per smartphone per month. So we'll have more devices, more applications, causing capacity and density challenges, driving the adoption of newer wireless standards. So let's now look at how wireless technology has evolved from an historical perspective. So during the days of first-gen Wi-Fi, where it was really about 11A/B/G, Wi-Fi was really deployed on a need basis. You had a couple of users in the enterprise, carrying laptops, and most of the time these laptops were tethered to a wired port at their desk, and they needed some connectivity when they moved into a meeting room. So wireless was really designed on a need basis. Next, with the introduction of 11N, we saw the growth of mobility. And in this period, we had users wanting to be more mobile on their laptops, wanting to access or wanting to be connected anywhere they move. And that primarily drove the adoption of 11N. And again, in this phase, what we saw was Wi-Fi being designed for coverage. The next phase was the age of BYOD. In this period, what we saw was users walking in with their smartphones into enterprises and wanting to connect to the enterprise network and access enterprise applications on their personal devices, be it a smartphone, be it a tablet, or be it their own personal computer. And now, suddenly, you saw a massive explosion of devices attaching to a wireless network. And we've really seen IT organizations step up and embrace this growth of devices into the network, and that kind of drove the next gen of wireless standard, which is the 11AC Wave 1. What we're witnessing today is, like I mentioned earlier, is the growth of IoT devices, which we will see growing massively over the next couple of years. And like I said, these include your wearables, your sensors at home, thermostats, etc. And these devices will demand Wi-Fi to be designed on a per application basis, and again causing both capacity and density issues, which we believe will drive the adoption of Wave 2 in the coming days. Let's look at some use cases across verticals for Wave 2. From an education standpoint, K through 12 and higher ed, we are seeing a lot of schools adopt a 1:1 device initiatives, which again means that the number of devices connecting to your network is going to grow, causing density challenges. And we've also seen schools and higher ed adopt new learning methods using rich multimedia content And these multimedia content demand higher bandwidth on the wireless network. So we see initiatives like digital learning, collaborative classrooms that will require more bandwidth to be available at the edge to be able to stream or make those rich multimedia content available to all the devices in the classroom. So from a capacity and density standpoint, some of these use cases will drive the adoption of Wave 2 in the education vertical. In the enterprise, we're seeing a wave where a lot of enterprises are moving to an all wireless workplace, where all the devices, including your laptops, your smartphones, your printers, your IP phones, use Wi-Fi as the de facto standard of connectivity to the network. Again, from that perspective, there'll be more devices that will connect to your wireless network. And with the BYOD trend that we're seeing, that'll just cause more density challenge in the enterprise wireless network. Also, we have seen that enterprises, users within enterprise use more collaborative tools, and these collaborative applications require more bandwidth to be available at the edge. Again, driving the adoption of Wave 2. In retail, we see retailers opening up their wireless network more for guests to be able to engage with them, to be able to attract them, and increase their loyalty. So they see Wi-Fi as a key component of their strategy to retain customers and improve loyalty. We also see a lot of IoT devices in retail environment, from smart kiosks to smart cards, POS devices, smart mirrors. And the growth of all these devices will again cause a density challenge for that environment. And of course, wireless is also will be more used by the store employees for their own productivity and use the tools they require to engage with the guest or with the consumer at the stores. From a service provider standpoint, clearly sorry guys. Okay, yeah. From a service provider standpoint, clearly they want to adopt the latest standard to provide latest technologies to their users. They want to ensure that they adopt the latest standards to provide value-added services, and also they see Wi-Fi as a key component to offload 3G, 4G traffic to the Wi-Fi network and free up the 3G, 4G bandwidth for other critical applications. So clearly, we see a lot of use cases across different verticals that will drive the faster adoption of Wave 2 in the coming days. So with that, let me pass on the mantle to Simon, who will now walk into details of Wave 2 technology itself. Just give me one sec. I have some problems sharing my screen. Okay, there you go, Simon. Can you see the new screen?
Yes, Tri, thank you.
Right.
I can see the screen. So with this slide, I want to bring to the attention that to make 11AC Wave 2 work, both the access point as well as the stations have to be, of course, 11AC compliant. And the Wi-Fi Alliance has a program to certify these products to guarantee interoperability. In 2015, many Plugfest has happened let's say, in the preparation for the official launch of Wave 2, which will happen in June, the end of June, the beginning of July of this year, 2016. So the Wi-Fi Alliance is ready for interoperability tests of the product in the market. If you look to the adoption of 11AC Wave 2, it's extremely high. What we've seen in both APs and stations. At least from Qualcomm side, we can inform you that the chips in the phones, tablets, and laptops that have been shipping for the last several years have been 11AC Wave 2 compliant. So it's especially important that the ecosystem is there from a station, from a client perspective. So when APs will be introduced in the market, the technology will be active and the benefits will be seen. Go to the next slide. So with this slide, I'm listing two key features of 11AC Wave 2. One is the increase of the bandwidth to 160 megahertz. And the other one is the introduction of 4 spatial streams. The reason for those is to increase the capacity to both devices as well as the spectrum efficiency in the air. If we look to some number examples on the left-hand side, I listed an access point with one antenna for the sake of understanding. And that one antenna AP would be communicating to a one antenna client, a cell phone in this case. So if that would be at a max bandwidth of 160 megahertz, the amount of bits that will be transferred at phi rate is 867 megabits per second. In the bottom, in the picture at the bottom, I show the spectrum efficiency, and what is interesting to see is that this one spatial stream of 867 megahertz is distributed over 2 chunks of 80 megahertz somewhere in the 5 gigahertz band. So each chunk of 80 megahertz will have a capacity of 433 megabits per second. So with the two combined, that will bring you to the 867. The advantage is that the 160 megahertz can be distributed in chunks of 80 megahertz over 3 channels available in the 5 gigahertz band. So a higher probability to find the 160 megahertz bandwidth. To further increase the capacity, 11AC Wave 2 is introducing 4 spatial streams. Each spatial stream is linked to one antenna. So to be able to communicate with 4 spatial streams, an access point will need to have 4 antennae. And of course, to be able to receive that, also the client will need 4 antennas to be able to get 4 times 867, a total of almost 3.5 gigabit per second of traffic. And in the picture below, you can see that each 80 megahertz chunk of the spectrum will contain 4 times 433, so 1733 megabits per second. So the aggregate will be equal to 3.5 gigabit per second. So I listed here the 4 antenna client. Of course, we all know that 4 antenna clients do not exist. So many, only when access points talk to each other. So that's why I want to introduce the multi-user MIMO capabilities on the next slide. So the circle on the left top shows the market distribution of clients, and 91% of devices that are out in the market have only one antenna, and only the remaining 9% will have 2 or more antennas from a client perspective. So that proves the point that 4 antenna APs will not be taking much advantage of the high capacity in the air, even a feature like multi-user MIMO would not be there. I show on the right-hand side that this asymmetry between the AP and the clients shows that in the top picture, what I called SU from single user. So this is let's say the legacy 11AC communication techniques. only one green arrow will be used. So that means that 75% of the capacity of the access point will not be deployed if single user would be deployed. That's why with the introduction of multi-user MIMO, all 4 spatial streams will be, let's say, active in the air at a packet transmission, and by means of beamforming, the 4 green arrows will be distributed to the location of the let's say the stations that are grouped. In this case, I showed 3 multi-user stations in a group, and the full capacity of the AP will be deployed. In the picture at the bottom, I give a number example how this works. In the let's say in the blue part of the presentation that I called SU MIMO, so the legacy 11AC device, if you have in this example 3 clients, a blue one, a green one, and an orange one, then these will have to communicate to the access point one at a time through time division multiplex. And while the instant capacity is with one antenna 350 megabits per second, megabits per second. So the ratio between the two, 117 and 303, gives you the MU gain, which is 2.6 in this example. On the picture on the right bottom, I explain the same information in let's say in a different style, where at the top row I indicate the legacy single user mode transmission, where the 3 clients will all communicate one at a time. And with the introduction of multi-user MIMO on the lower part of that picture, you can see that the blue, the green, and the orange will be all served at the same time, and with an MU gain of 2.6. In about 40% of the time, the information will have been sent across, and the yellow box shows the additional time that is made available that can be addressed by the access point to serve other MU clients or maybe even SU clients. If SU clients exist in the group, and that is very likely between now and 2020, legacy devices will be there for a long time. The yellow time can be used for SU devices as well. So in a mix of multi-user and single-user clients, we see that all the clients, all the stations will benefit from the higher capacity made available through MU. So we can go to the next slide, where we focus in on the chip. The Qualcomm chip used in the product is QCA9994. This is our 11AC Wave 2 AP chip, and the key features are listed in the box on the left. So with a 4 antenna device, we provide 4 spatial stream at 80 megahertz, and in the 160 megahertz mode, or 80 plus 80, as we also call it, we will be able to provide 2 spatial stream to have a fire rate capacity of 1.7 gigabit per second. That results in 1400 megabits UDP and about 1300 megabits at TCP in, let's say, user experience throughput. In addition to multi-user MIMO, the product also is able to perform transmit beamforming. That means that when legacy single-user devices are used, let's say the energy can be concentrated at one point in the spatial domain to increase the mid-range capacity. Higher MCS rates are typically resulting because of beamforming. So it gives increased user experience as well. One of the key features of the product is that we are able to support 512 users that stay associated and will be actively served. We've seen in the past that wireless access points, when many clients are connected, there is not much space to be able to serve, let's say, those clients. But with the introduction of QCA 9994, we will be able to serve this high amount of users all at the same time. Another key feature is what we call the packet-by-packet switching. So an AP, of course, is serving many different types of clients that are either 20, 40, 80, or 80 plus 80 megahertz wide. And we will be able to serve all those clients at packet-by-packet basis. So at one transmit opportunity, we transmit at 20. And in the next transmit opportunity, we do that at 80 plus 80 or 160 megahertz to get max capacity over the air. An important feature also is bandwidth agility. So in busy spaces like public spaces or office environments, you see many APs in a small environment. So interference can occur to the AP, and if such interference occur, the QCA 9994 will reduce its bandwidth when needed, but at packet-by-packet basis, it will go back to the max available bandwidth when interferers have, let's say, have disappeared to get max capacity. Another key feature is the fact that we support a spectrum analysis unit for monitoring and diagnosis of interferences that will help also for radar detection and other, let's say, spectrum aspects to act accordingly to the regulatory domains. In terms of adoption, the QCA 9990 is the product that is Wave 2 compliant with 80 megahertz only. That was introduced in January of 2015, and the QCA 9094, the product that we talk about today, is in production since September of 2015. The picture on the left bottom is let's say a performance picture that I took from our interoperability test. Qualcomm is putting in a lot of effort to guarantee interoperability and to optimize interoperability between all the clients that are available in the market. And you can see here that the blue bar that represents the QCA 9994 shows the throughput in megabits per second for a group of devices that we test for interoperability, and we compare that how we do compared to the industry, which is listed in red as the best competitor. And you can see that from interoperability perspective, we are either at par or in most cases performing better than the competition. So high performance is achieved through the extensive interoperability test and optimization that we perform. The picture on the right shows the multi-user MIMO capabilities. It is important to understand that dependent on the distance to the access point that is indicated with the plus horizontal axis, that multi-user MIMO gain that we talked about earlier is achieved at short and mid-range. So that's where the maximum 2.6 gain is achieved. At the far end, when signal-to-noise ratio is, let's say, is at its lowest, devices will be optimized to perform at let's say, max range, which is achieved with the single user capability. So that's why single user and multi-user curves will merge at the far end. So multi-user will not increase the range, but it will increase the capacity by a factor 2.6 in mid and short range. So that concludes my introduction of the chipset, Sri. So you can pick it up from here.
Thanks, Simon. That was a great overview of the Wave 2 standard. So, folks, let me wrap the session by giving an overview of our newest access point, the C120, that we announced in Jan this year. So again, this will be using the latest generation of Qualcomm chipset that Simon just talked about, the QCA 9994. This is going to be a beast of a platform, very powerful. It will be a 4x4 MU MIMO, Wave 2, obviously support channel bonding 80+80, up to 1.7 gig on the 5 gigahertz radio and 800 Mbps on the 2.4 gig. And like Simon mentioned, we will be able to support multiple clients, streaming to multiple clients simultaneously at the same time. So, so if you're looking at upgrading or greenfield deployment, irrespective of what vertical you are, I think the Wave 2 is something you should definitely consider, and the C120 from an availability standpoint will become generally available early Q2 this year. So with that, we come to the end of today's webinar. We have quite some time open up for questions. So Erica, if you want to bring up all the questions, we can address them.
Great, thank you, everyone. And just to review the slide that Sri is showing right now, for all those eligible attendees, we will be reaching out to confirm your free access point. If you have any questions, you can contact your Mojo Networks rep, or give us a call or send us an email at myrep@mojonetworks.com. There are some eligibility requirements that are posted on the webinar page. Again, please let us know if you have any questions. As the questions have come through here, I just want to get started. It looks like a couple are going to be for our presenter, Simon. There's a question here. Do you also require clients to support Wave 2 for multi-user MIMO to work?
Yeah, so I showed in the let's say in the presentation that to be able to make multi-user MIMO work, both the access point and the client will need to be multi-user MIMO capable. So only those multi-user MIMO clients will be grouped and will be served in, let's say, at the same time as I explained. If a device would not be multi-user MIMO capable, no problem. The access point will serve that client in the single user mode. But of course, it will not be grouped with let's say with others. So the capacity of the air will not increase. The client will not let's say see any drawback, but the max capacity will not be used to its max over the air.
Great, thank you. I have another question here. It looks like this might be for Sri. What scenarios do you see 80 megahertz and 160 megahertz channel width deployed?
Okay, great question. I think it really depends on the environment, on the deployment environment, right? So first off, it depends on how many access points are deployed. Is it a high dense environment or is it a sparse AP deployment? And also depends on whether you've planned the network to use the DFS channels. So today, if you discount the DFS channels, there are two 80 megahertz channels that you get, non-overlapping channels. And to me, if you design your network not considering DFS, then clearly 80 meg and 160 meg are out of question. And also for high dense deployment, like stadiums, auditoriums, it's actually recommended to use lower channel width. 20 or 40 megahertz, depending on the channel reuse that you want to achieve in your RF environment. So yeah, I mean, again, it's depend on the RF environment, depend on whether you want to plan using the DFS channels or not.
Great, thank you. Another question came in here for Simon. Can you dive into a little more who you compare your chipset with in the chart where you show the best industry performance?
Yeah, I'm happy to answer. So what we typically do, so in this 4-antenna device, we have taken, let's say, the industry available products that have 4x4 chipsets in it. So all the vendors, all the silicon vendors that provide 4-antenna chipsets have been used in comparison. Yeah, so all 4x4 chipset vendors have been used in comparison, and I think you all know who these competitors are, right?
Great, thank you. Another question here. How do you overcome the 1 gigabyte wired bandwidth bottleneck?
And that's a question for Sri or for me?
Sri, can you answer that?
Could you repeat that question again?
Of course. How do you overcome the 1 gigabyte wired bandwidth bottleneck?
Oh yeah, great question. So I think first off, when you look at the actual throughput that you would get from an access point, in most scenarios, given the distribution of clients, you will not cross the 1 gig barrier or 1 gig throughput performance from a single access point. And of course, there are different standards that's been worked on in the industry. The multi-gigabit that supports multi-gigabit on the existing wired deployment, and that's a standard that we are closely following. I believe there are 2 different standards in the industry. It's at least a couple of months away before IEEE standardizes on one of them. And once IEEE standardizes on one of them, we will closely look at that specification. And as the chipset vendors like Qualcomm add support for multi-gigabit on their platform, we will definitely add that to our product portfolio.
Fantastic, thank you. I believe this question is for Simon. What data cables would you recommend for a Wave 2 access point?
Sorry, you said what? Can you repeat the question? I couldn't hear the word.
No worries. What data cables would you recommend for a Wave 2 access point?
Data cables. So I assume this is linked to the Ethernet cables that are connected to APs.
For example, a dual Cat 6A.
Yeah. So maybe Sri, you can help me here in terms of what you recommend from your product perspective. But if let's say a gigabit per second of data will be offered through the cable, then we need to have Ethernet cables that will be gigabit Ethernet capable, right? So Cat 5e and Cat 6, I think, are the typical Ethernet cables used.
Yeah, that's correct, Simon. Yeah. So today the C120 Wave 2 access point will support dual gig port, where you could, though it's not a common scenario to pull cables to both the ports, but if you really wanted extra capacity, you could pull both the cables and link aggregate across both the ports. But like I said, like Simon mentioned, you should definitely plan for 1 gig ports, because the throughput from the Wave 2 access points will definitely need a 1 gig port connected to your access point.
Thank you. There's another question here asking for some additional detail around the communication occurring between the WAP and the cloud-based controller. So Shri, maybe you can help take that. Exactly what kind of traffic is exchanged and what happens if the network, what happens to the network if the controller becomes unavailable?
Okay, so great question. First off, we don't. The first thing is to note is we don't have a controller on the cloud. It's not a controller architecture like other competitors. It's a pure controllerless architecture, and the only thing that goes back to the cloud is management traffic. So configuration pushes from the cloud to the APs, stats for monitoring, troubleshooting from the AP to the cloud. Those are the only management traffic that AP and the cloud talk between each other. And that communication is sent on a secure encrypted channel. And to answer the second part of the question, which is what happens when the cloud connectivity to the cloud goes down, like I said earlier, we don't, our architecture is not controller based. The way we have architected our cloud and AP is we have completely decoupled the control plane, management plane, and data plane. So the only thing that resides on the cloud is a management plane, and the entire control plane and data plane is at the access point. So even if for some reason the connectivity to the cloud goes down, the APs can still continue to serve clients. New clients can associate. Existing clients can continue to send traffic. There will be no impact. But also, APs will still continue to do intelligent wireless functions like roaming, fast roaming, reacting to channel interference, changing transmit power, etc. So basically, there's no impact when the connectivity to the cloud goes down from an access point perspective.
Great, thank you very much. And there is a couple questions here coming in, so I'm just going to give those another minute. Shri, I have a question here for you. Can you please describe what is lost when PoE plus 802.3 AT is not available for the access point?
Yeah, so the C120 will support both the modes, PoE plus as well as PoE, standard PoE. Definitely with AT, PoE plus, you get the full functionality on the AP where you'll have both radios operating 4x4. When we make the product available, we will qualify what the functionality of the AP will be in a PoE mode.
Okay, and further on that question, what about cellular assistance?
Sorry, Erica. Can you just come back?
It looked like it looked like a follow-up came into that question, but I'll follow up with the attendee to get more details. Okay, another question here. Does Mojo GUI Management Console support remote monitoring tools to include spectrum analysis, client health monitoring, etc.?
Yeah, absolutely. So great question. Today we extract a lot of information from the AP that is that we show on the UI, and when we start supporting some of these new Gen chipsets, we will definitely look at what more information can be extracted or is available from the chipset, and make those information available on our console.
Great, thank you very much, Shri. Looks like I just sent you a few more questions that came in. Hopefully we'll have time for those. I know we want to wrap it up here, and we're getting close to the hour. So I'll also give a chance for any more questions to come in. Please submit them through the Q&A window. Again, if you have any other questions, feel free to also send us an email at myrep@mojo networks, and we will get back to you as soon as possible. And then Sri, there should be a few questions for you in the chat window. It looks like we have quite a few more questions coming in here. So if we don't get to everyone, we will follow up individually. I do have your questions here. There's a question around, is there any future support for OpenFlow or SDN controllers?
Not at this time. But that's something which we're keeping a close tab on. Generally on the open deployment, but not at this time.
And the question came in around how to upgrade from a Wave 1 client to Wave 2. Is it a software upgrade or a hardware upgrade?
That will require, Simon, you can help me out here, or you can answer here, but that will require a new chipset, which means it will be a hardware upgrade to go from Wave 1 to Wave 2.
Yeah, I can confirm that there is quite some difference between Wave 1 and Wave 2. For Wave 2, there is a special sounding sequence needed between the access point and the clients to be able to perform the MU features, and that requires hardware. So the chip is typically another chip supporting Wave 2.
Great, thank you very much, Simon. I'm going to go ahead. There's a couple more questions, but I think we'd like to follow up with these offline so that people have some very specific product questions, and I'd love to be able to provide more detail to those individuals after the call. So we will follow up with you individually. Again, if you have any questions, you can also feel free to contact Sri directly, SRIRAN @mojonetworks.com, or myself, Erica, ERIKA, @mojonetworks.com. We will get back to you as soon as possible. I will have a recording of this available, and we'll send it out to all those attendees, so you can feel free to forward this on to any of your colleagues who missed the call. Again, we thank everybody for their time and for joining us today. We understand this is your schedules are very busy, so we appreciate you joining, and we look forward to seeing you on our next event. Thank you very much, Simon and Sri.
Thank you, folks. Thanks for joining today.
Thank you.
Have a good one. Bye.